Assalamu alaikum students, how are you? I hope you all are fine. We have started our 11th chapter, which is alcohols, phenols and ethers, and in that we were talking about reactions of alcohols. And I told you alcohols react in two ways: the reactions in which CO bond is broken and the reactions in which OH bond is broken. So when the nucleophile attacks, the carbon oxygen bond is broken, CO bond is broken, and the hydroxyl ion is replaced by some other group, right? But when the electrophile attacks, the OH bond, oxygen hydrogen bond, breaks, and some other group takes the placement of H positive, right? So H positive goes out, some other groups come in, and they become attached with O negative. So first of all, the first group of reactions which we are going to start is the reactions in which CO bond is broken. So ethanol reacts with thionyl chloride in the presence of pyridine. Its hydroxyl group is removed and it is replaced by chloride ion. SO2 gas is released and HCl is produced. Basically, thionyl chloride is a source of chloride ion and it attacks the CO bond which is broken, hydroxyl ion is removed, and then the C forms the bond with chloride ion. And byproducts are SO2 gas and HCl, and the reaction occurs in the presence of pyridine. The second reaction is the one in which ethanol reacts with HCl in the presence of zinc chloride. Again, CO bond breaks, OH is removed and is replaced by Cl, and ethyl chloride is formed, and the byproduct is water. The third reaction is the one with ammonia, NH3. NH3 has basically two groups. NH2 carries negative charge and H carries positive charge. So here when CO bond breaks, hydroxyl group OH negative group is replaced by NH2 negative group, and the product becomes ethyl amine. NH2 is amine, C2H5 is ethyl, so the product is ethyl amine, and the water is released. OH from here and H from here form water, and the reaction occurs in the presence of thorium oxide. So basically these were the three reactions in which CO bond was broken and hydroxyl ion was replaced by some other group. The second group of reactions are those in which OH bond is broken. So when OH bond breaks, H positive is replaced by some other ion, right? Okay. The first one is in ethanol reacts with sodium. OH bond breaks, H is removed and it is replaced by Na positive. It forms sodium ethoxide and H2 hydrogen gas is released. Why we took two molecules? Because hydrogen gas here only H from one molecule, one H positive is released, but from two molecule, two hydrogens are released and they form hydrogen gas. Okay, in second reaction, ethanol reacts with Grignard reagent. Grignard reagent also has two ends. One is partial negative and the other one is partial positive. CH3 carries partial negative charge and magnesium carries partial positive charge. So when here H positive is removed, it is it combines with the negative end of this. Let me mark again. Positive end of this molecule will combine with negative end of this molecule. All right, it will form CH4, and negative end of this molecule, C2H5O negative, will form a bond with the positive end of this molecule. So C2H5O combines with magnesium, which is connected to iodine, and the other product is CH4, which is formed by CH3 negative end of this group and H positive end of this group. CH4 methane is formed. In third reaction, ethanol reacts with acetic acid in the presence of H2SO4, and ester is formed in the presence of water. How ester forms? Basically H from ethanol and OH from carboxylic acids are removed to form water, and the other group C2H5O and CH3CO. These two groups unite to form ethyl acetate, which is ester. Alright. Now coming to some other reactions of alcohols. First one are oxidation reactions. Oxidation reactions of alcohols, Basically, aldehydes and ketones are formed. In case of primary alcohols are those in which the hydroxyl group is attached to the carbon, which is further attached to only one carbon. Okay, so in case of primary alcohols, the hydroxyl group is oxidized to acid aldehyde group. All right, so sorry, aldehyde group. Hydroxyl group is oxidized to aldehyde group CHO, and the reagent used is potassium dichromate A2Cr2O7 in the presence of acid H2SO4. So it is known as acid dichromate. In second reaction, as you can see, it is secondary alcohol. Secondary alcohol is the one in which hydroxyl group is attached to the carbon but is further attached to two other carbons. So secondary alcohols के case में क्या होगा? The hydroxyl group will be oxidized to form ketone. तो यहाँ पे जो कीटोन बनी है, it is known as acetone or propanone. Again, the reagent is same, acid dichromate. But in case of tertiary alcohols, tertiary alcohols do not oxidize easily, they are resistant to oxidation. But in the presence of these reagents, which were given to primary and secondary alcohols, what happens is that elimination reaction occurs. Elimination reaction is the one in which some group is eliminated, all right? So from second tertiary alcohol, water is removed. How? This carbon loses hydroxyl, and this carbon or any of these three carbons, they all are equal. So any of this carbon will release its hydrogen. Okay. For example, this carbon has three hydrogens. If it releases one hydrogen, this hydrogen and this hydroxyl will form water. But in this case, hydroxyl is negative. So when hydroxyl leaves with the bond, hydrogen leaves donating the bond to the carbon. Do you remember this? When one group leaves with the bond, the other group leaves without the bond. So this hydrogen, one of these hydrogens, will give the bond between these two carbons, and the hydroxyl group will be removed with the bond, right? So hydroxyl is removed with the bond, hydrogen is removed without the bond. Hydrogen gives its bond between these two carbons, and they form double bond, and the water is released. Here it's a mistake. It's not CH3, it's CH2, because one hydrogen has already been removed. So CH2 double bond C, CH3, CH3, and the hydrogen water. So this was 2-methyl 2-propanol. How? First, select the longest chain. Let this be the longest chain, 1, 2, and 3. Second carbon carries hydroxyl, second carbon carries methyl. So 2-methyl 2-propanol, because there are 3 carbons in the long chain. Coming to this one, select the longest chain. The longest chain has to be this one, which is propene, because it has 3 carbons in it, and at second carbon methyl is attached, so 2-methyl propene. Okay. Okay, second group second group of reactions are those named as dehydration. Dehydration, as the name suggests, is the removal of water. D means removal, hydration means water. So water is removed from alcohols in the presence of some dehydrating agent, which is concentrated sulfuric acid. So basically, alcohols react at two different temperatures with concentrated sulfuric acid to give two different products. The first one is the ethanol reacts with concentrated sulfuric acid at 180 degrees centigrade and gives ethene. In second reaction, ethanol reacts with concentrated sulfuric acid at 140 degrees centigrade and gives diethyl ether. What is the mechanism behind? Let's see over here. The ethanol, this is the ethanol, right? I have opened one hydrogen of this group and hydroxyl end of this group. ठीक है, इसमें CH2 और एक हाइड्रोजन ओपन करके लिख लिया और एक हाइड्रोक्सिल एन. हाइड्रोक्सिल क्या करेगा? अपना बॉन्ड लेके जाएगा यहाँ पे, और हाइड्रोजन क्या करेगा? अपना बॉन्ड दे के जाएगा, और ये क्या रिलीज होगा? वाटर. ठीक है. सो अगर एक बॉन्ड लेके जा रहा है, एक बॉन्ड दे के जा रहा है, तो यहाँ पे क्या बनेगी? इथीन. Okay, so this is when the alcohol reacts with concentrated sulfuric acid at 180 degrees centigrade. And the second one is when the concentrated sulfuric acid reacts with ethanol at 140 degrees centigrade. Here, two ethanols react with each other and water is removed. How? H from one hydroxyl and OH from other hydroxyl, they give water. What is left behind is C2H5O, C2H5O, and C2H5, which is ether. So ethyl, this is ethyl, this is ethyl, this is ether. So the name is diethyl ether. Okay. So here you saw how ethanol reacted with concentrated sulfuric acid at two different temperatures to give two different products. In both cases, water was removed, right? Okay. Third group of reactions is which in which the alcohol reacts with phosphorus halides. Phosphorus halides means something related to halogens, phosphorus, compounds of phosphorus and halogens, PCl3 and PCl5. So both are basically the source of chloride ion. Ethanol reacts with PCl3 to form ethyl chloride and H3PO3, which is orthophosphoric acid. And also ethanol reacts with PCl5 to give ethyl chloride, and the byproducts are POCl3 and HCl. So basically these are the source of chloride ion. Okay. I think that's it for today. We'll start this topic tomorrow, inshallah. Till then, Allah Hafiz.